Okay, so I really wanted to do a probability video, and this one was tricky for me because I know that all of the problems that students are assigned are very, very different. So I came up with 4 that I'd like to do with you. And these are just examples, so you could use them to do a different problem that's similar. So the first problem is Jake is tossing a 6-sided number cube, which would basically be a standard die. What is the probability of tossing a 4 2 times in a row? Okay, so you have to think about the probability of the first roll. So the first roll, one of the sides out of 6 is a 4. And then you multiply that by the second roll. So if you toss it again, the chances of getting a 4 are 1 out of 6. So if I toss the first one, and then I toss the second one, the chances of me rolling a 4 2 times in a row are going to be 1 in 36. Because 6 times 6 is 36, 1 times 1 is 1. So the chances of me rolling a 4 2 times would happen 1 in 36 tries. Okay, let's try another one. So this time, a fair die is tossed twice. What is the probability of getting either a 2 or a 4 on the first toss, and any of the 3 numbers 1, 3, or 5 on the second toss? Okay, so the first toss looks like this. There are 6 sides, and 2 possibilities are good. The second toss looks like this. There's still 6 sides of the die, and 3 of the numbers are good. They are favorable according to what we're looking for. So now I'm going to multiply across the top. 2 times 3 is 6. 6 times 6 is 36. In this case, this is a fraction that we can reduce. We're going to divide by 6. The numerator becomes 1. The denominator becomes 6. So there's a 1 in 6 chance of rolling a 1, 3, or 5 and a 2 or a 4 on 2 separate rolls. Okay, let's try this one. In a basket out of 30 fruits, 3 are plums. 3 fruits are selected from that basket. What is the probability that all 3 fruits are plums if the first and second fruit are not replaced? Not replaced. So this one's a little trickier. Okay, so on the first try, 3 out of 30 are plums. Out of the second try, I already have 1 plum. I'm not putting it back. So now I'm out of 29. Only 2 of them are plums. So we went from 3 out of 30 to my chances being 2 out of 29. The next time there's only going to be 28 plums in the basket, and 28 fruits in the basket, and 1 of them is going to be plums. So I'm actually going to use a calculator because these numbers are going to be a little bit bigger. So here's what we're going to do. We're going to do 3 times 2 times 1, which you should be able to do in your head. We're getting 6 for the top, the numerator. On the bottom, the denominator is going to be 30 times 29 times 28. And we're going to get a huge number, 24,360. I'm looking at this number and I'm thinking to myself that this probably can divide into this. So we can probably divide 6 into the number. So we're going to divide by 6. Awesome. So the numerator can be a 1. The denominator is going to be 4,060. So there's very low probability of pulling all plums out of a basket of 30 fruit. Let's try one more. Okay, so this is a standard deck of cards, and for probability problems you need to know that a standard deck of cards has 50 52 cards. You also need to know things like there are 4 of each number in a deck of cards. There are 3 face cards per suit. These are just things that you need to know, and if you don't know those, you need to look them up. You need to know some standard things about a 52 pack of cards, deck of cards. What is the probability of drawing 3 kings from a deck of cards if the cards taken out each time are not, keyword, replaced? Okay, so there are 4 kings in a deck of cards. So on the first try, you have a 4 out of 52 chance. On the next try, it says they're not replaced, so now we only have 51 cards. And if the first one was a king, there are only 3 kings left. Okay, now we're on to the third try. I pulled out 2 cards already, so there's only 50 cards left. The first 2 were kings, so there's only 2 more kings left in there. So now we're going to multiply. Okay, again, we should be able to multiply across the top. 4 times 3 times 2 equals 24. Numerator's 24. Now the denominator's a little trickier. 52 times 51 times 50, a huge number. 132,600. Now because I know this, I know that 24 is going to go into that. If you don't know, you need to do a guess and check on your division. You need to find something that can go into the numerator and the denominator equally so that you can reduce this fraction. So I'm going to divide by 24. So my numerator is going to become 1 because 24 divided by 24 is 1. Now the denominator is going to become 5,525. So what you're basically doing is you're finding the chances of the first thing being what the question asks, or favorable. The second chance being favorable. Then the third chance being favorable. You multiply. So basically probability is a lot of multiplying favorable outcomes.